Hey folks, welcome to the SIG Node weekly meeting, August 27, 2024. We have a couple of items on the agenda. First up is Laura with crash loopback customization. Go ahead.
Hi, thank you. Share this again so everybody can see. Okay, hi everybody. My name is Laura, if I haven't met you before. I have been working on crash loop backoff. I'm going to talk a little bit about the history of that in the slide deck too. But I think the last time I presented here was quite like 2 or 3 months ago related to 131. And I want to talk today about what we're doing in 132 and beyond. And I know some people know a lot of this background from commenting on the CAP or other one-on-one meetings, but I'm just going to say a bunch of stuff from the beginning in this forum. And then, as always, I'm interested to discuss some stuff today. DM me anytime on Slack, and then talk more on pull requests as usual. Okay, so again, starting just a little bit from the beginning to make sure we're all on the same page. Crash loop backoff, as probably a lot of people here already know, is designed to slow the speed at which failing containers restart. So a container, if it exits, then it will have this backoff delay as to how soon it can restart if it has a restart policy that's different than never. Today it's a fixed behavior of starting at 10 seconds and increasing to X at each restart iteration up to 5 minutes, and then just continuously 5 minutes max from there on. And there is a issue in open source that in the upstream that has lots of positive reactions of people asking for this behavior to change. And then also there's some specific types of workloads that are getting more popular, like gaming and AI/ML, that care a lot about the restart behavior and being able to restart faster to prevent, for example, like highly coupled containers or pods from getting in like staggered restart states where they can't cooperate well anymore. And I mentioned this a little bit before, but here's a graph version of it, that today, if a pod has a restart policy besides never, then anytime all the containers exit, then the kubelet will restart them, starting at 10 seconds and then increasing to X as it continues restarts. And eventually that delay will reach 5 minutes, and then it will stay at 5 minutes forever after until that pod stops exiting. Curating through the issue that I mentioned earlier, there's kind of 3 big categories I find of people's problems related to this. Some of it is that this crash loop delay occurs even if the container exited with the succeeded status. So some people feel that successful containers are being unfairly penalized and they should actually get a free or faster restart and not have to crash off like this. There's early recovery concept. So some people are like, oh, my container has could recover on its own. If we could just like restart faster, it would self-heal a lot better. And then we wouldn't need to, get paged or like involve ourselves or whatever. And particularly really, really super important containers like sidecar containers that are doing logs monitoring or networking is really important to people for those purposes. And then there's kind of a late recovery concept, which is containers that maybe did like legitimately crash and aren't going to be able to recover super easily on their own. But if they did try, at least like tried their best, they will still have the same delay regardless of if they were like better behaving or not. And by better behaving, usually that means like it at least ran successfully for some amount of time, or like its readiness probe actually like responded something positive, but sometime later in its life cycle it still crashed again. And today, people try to restart the backoff counter so that they can get back to the beginning by just kicking old containers, but then they lose their pod logs and their history, and sometimes they need those. So that's another category that people can be in. Overall, this is like kind of a really fundamental inside piece of kubelet, and it's been working pretty good so far. But also, as I understand, it was like super arbitrary the day that it was invented, like why it is those numbers, and like, obviously that seems to have worked out for a lot of people for a lot of time, but there's people who have issues with it too. So what we were trying to do with this in 131 and also now in 132 is to try and improve this pod restart backoff logic to better match the load that it creates. So we know some more about what types of workloads and how they behave. We have feedback from users about why something is too slow or not for them. So we can try and tune it better to that or provide them knobs to tune it. But the second point is we know that part of the reason that this even exists is because it's a node stability issue. If there's one like runaway pod that's just crashing all the time, it shouldn't just get to like go all the time in DDoS kubelet. I'm really interested in being able to empirically derive these defaults and allowable thresholds. So like doing some sort of load testing or benchmarking or including that in our conformance testing so that we know over time that whatever we choose to change is safe. And then one really important thing I think that has affected the design, both in 131 and 132, is we want to provide a really simple UX that doesn't require too many changes for the majority of workloads. So there's potentially like a rising tide lifts all boats kind of thing going on if we could make it just like better implementation on the inside for everybody that is recognizing what the real load is on kubelet, and making restarts faster if we can for everybody without them having to do a lot of configuration. That would be cool. And then if we do need some configuration to do something even more aggressive than what we know would be still good within node stability, then that's okay. There was a whole plan in 131, which involved kind of like changing a couple different things, and trying it out, and seeing how people go. This is kind of a graph of that to show that I was interested in changing the curve that we have today to be really flat for succeeding containers, not as flat for the general case, and then to provide an API per pod, to specify if it should be an even faster back off, something in between kind of like the new standard and success, which was going to be the most aggressively restarted, and see how that goes. The biggest issue we had with this in 131 and why we postponed on that is the place that I proposed to put this was in the pod spec. And two things. One, there's like a really long API stabilization process to like add another enum to restart policy, which is specifically where I wanted to put it, because you need to be, according to the API deprecation or like update policy, we need to be back compatible with kubelets 3 behind. And since this is a known field to current kubelets, then there's kind of like a on-ramp process that would have to happen. But even irrespective of the API concerns, this would put both this and allowing for fast restarts on success, kind of the power of whether something, a given container is going to like restart really fast in the hands of somebody who is the application developer, because they can catch every exception and exit 0 inside the logic of their container, or just anybody who has access to the pod spec, which is maybe not the same person as like a cluster operator. That might be something that is delegated to the application developers, but they don't necessarily have the full view of all the other namespaces or in all of the other like teams that are using this cluster, like what's the impact of that. So it was kind of like, is this really the place where we should put this knob, that it doesn't have a lot of oversight from the perspective of the cluster operator. So new version for 132 is that we're considering instead to expose something in kubelet config so that the cluster operator, who has more control over the kubelet config, can specify some level of detail about how should I change the crash loop backoff for this kubelet here in this node. There's a couple variations which have been floated, which I would love to discuss here if we have some time. But I want to bring up that while we do want to try this out for 132, and we think that this is a good like pressure valve knob, both for now and in the future. There's been a lot of chatter and feedback about this proposal about well, what's the perfect like system where kubelet like knows, like has a budget of how many restarts and other stuff that it can do. And there's some hierarchical token bucket or quota or something where like things are like, yo, kubelet, can you do my thing for me now? And kubelet's like, hold on, I'm not ready yet, or whatever. And notably here on this bullet point right here, there's some overlap with another kept in flight sub-second probes that also might be in this category in my mind of things that could be hitting kubelet more. And if there was like a more holistic overarching budget of like, hi, I'm kubelet and I don't know if I can give you a pod worker for that right now, or something like that, that might be useful. So there's a lot of interest, at least when I'm getting feedback about this, about not kind of patching on some rate limiting, or not only doing the analysis of like what can kubelet stand today, and can we like put in the benchmarking to try and track that down in the future, but that's still like a little bit more reactive. But can we make a system that kubelet is able to like tell people to back off when it feels like it? So yeah, that's like kind of the direction that is going for 132, so that there would be this in alpha, something that cluster operators could use right now, and then that there's a future integrating more with things like sub-second probes or other projects that are in this space to figure out, is there a way that we can establish against at least the kubelet component how it can have a budget for these types of requests. There's a bunch of other slides in here of like some back research about like what's happening when things restart, and even more details about those things that I'm happy to discuss at a later time, or now if people want to. And I also wanted to mention that I did some experiments where I like had my own like set a kubelet to have 0 back off, 0-second max, hit it with 110 pods that were crashing, simultaneously crashing every 0 seconds, and observe some of the, just like from the outside, observe some of what was going on. And the biggest observations I had was the container runtime usage. The CPU would like go really high, especially at that time when it was like all the pods are trying to happen right now, as we might expect, but this was like the quantification of that. And API server also, as we might expect, had a lot of like pod status updates, which also increased a lot until it got rate limited eventually. And the reason I want to bring this up is it was cool to see that like, even if I make it really mean, like the whole thing doesn't fall down, it just like the stuff changes. But this also identified to us, like, are there, maybe some places where the pod status is being updated that could be batched, or that like we could defer, or like, are there too many of those? Is that something we could tweak to if we knew that we were going to make restarts happen faster, or allow people to make them start faster? Is this like a optimization that we could improve? So I would love to pause there and transition to discussing a little bit about these possible ways that a cluster operator could configure their node. The most basic, so these are all examples of like what could a kubelet config look like in this world. And one of them might be for the basically variables that are hard coded right now. The base number, like what does the backoff start at? The max number, what does the backoff end at? And the rate, how fast does the backoff change? We could just like expose those as like, for this kubelet, these are the things, you can change them. That changes for all the pods, all the init containers, all the jobs, all the everybody for this node. And this is like something that's being directly asked for, configurable by node or per pod for that matter. But we talked about why we're kind of not into that right now from 131 on the issue that I mentioned before. Another idea has been, don't put all those knobs in there, but put some, at least max, and then internally determine if we are hitting that max with like the original setup or not. So this kind of takes the like detailed configuration out of it and makes it a little simpler. And if this max is set to like 5 minutes or 10 minutes, like really it's just going to operate like it does today, where it's going to max out at 5 minutes because that's going to be the smaller of the two. But this was an idea. There's another idea that
I think we lost our audio.
Yeah, sounds yeah.
hello again.
Hey,
Yes,
yeah, we can hear you.
Okay,
Hey.
I'm sorry. Woohoo, that was exciting. I'm resharing my screen. I think it's out there. Okay. I feel like people started looking at me weird when I was talking about this readiness probe one, so I'm going to start there. Okay, so this idea here is, why don't we reward pods that have been doing well in their recent lifetime? So in some window of time or some window of restarts, can we check like what their past readiness probe successes were, or their liveness probe successes, and reward them with a better max, like the configured max by the cluster operator for having done so. So this is an idea. And then a last idea that we have, which kind of ties in some of the things we are interested in for the 131 proposal, is can we specify enough configuration that the cluster operator in kubelet config can like limit the blast radius basically of where this max is being configured. So for example, can they say just this namespace, like this rapid namespace or this rapid label or this like whatever, it doesn't have to be namespace, but something that like I could set some policy on, or I could like restrict access to. Can I set the max there for this node to be different? And then somewhere in kubelet, it's going to check. We have to change it to check to see if this is a pod that meets that criteria. Then you get the faster or at least different max, and congratulations to you. So these are the current ideas on the table. I would love thoughts. I will take them now and later, and I don't mind sharing a link to the presentation. It did get dropped in the notes earlier today, but I'm going to put it in here real quick. There we go.
Thank you.
Yeah.
Did we consider using pod priorities as something that plays into it?
Yeah.
Yeah.
Yeah, that has been discussed in this, like when we have a budget. So like kind of in this like future world, which again, I'm kind of trying to like split the difference between like something that we can get some signal from people now and like expose something that cluster operators can use. And when there's like a world that is a lot smarter. Yeah, I think some sort of quality of service or pod priority would likely factor into the any sort of quota system. I'm just reading the chat too.
Hi, I do have one question.
Yeah.
You answered mine about the image pullback offline, and that's fine to target this
Oh, yeah.
one
Hi,
for this.
Kevin.
But I guess one thing, like in my experience, a lot of people don't really like the infinite loop back off.
Yeah.
And they would like to actually have the pods like fail so that they're removed from using resources. Have you considered like having like a max limit in this API?
And then the pods are like deleted and rescheduled, you mean?
Yeah, if it's a workload, I would imagine like a deployment would remove that pod and then create it elsewhere. Like this happens a lot like for devices that are having issues.
Yeah, I would say at least from like the comments that are on like the issue that I'm sort of deriving this like user experience from, there's a lot of people who specifically want the restart not to get rescheduled because they don't want to have any scheduling time. They also don't want to delete the pod history. So there's kind of a combination of those factors that people are, you know, kind of depending on implementation detail of restart. But that is like a specific use case that I'm keeping really top of mind, I guess. Don, did you have a comment on that too, or different?
Yes.
Yeah, go ahead.
I want to follow up the Karen's problem. So the question, and we did discuss at the earlier Kubernetes design. The problem it is Node don't have the global knowledge, right? So Node cannot make decisions. So instead, we give that all the details, why the running container is failed, what's the reason, and also the restart count. So we do have the restart count and all those things. And then we introduce of the controller, which is many different type of the jobs. So they need to monitor those kind of things and decided to reschedule this to the different node. The problem it is on the node, you could, people just say, okay, node is just basically on this particular things, node only knows why, even don't know why workload is not succeed, right? So some it is on the no-code environment, right, runtime environment. Some is just because workload itself. So this is why we are relying on the controller have the global knowledge to make the best decision. So that's kind of what we are doing. Yeah. So.
Did that answer your question, Kevin, or not?
I mean, I guess, yeah.
A little bit.
No, it does. It's just, yeah, I'm just wondering, like, for an AI use case of, like, that tends to be like where I've heard a lot of the,
Okay.
you know, having pods kind of get rescheduled because you want to, if they're like failing because of an application error, even though they're in a crash loop back off, they will be infinitely crashing unless somebody comes, like, unless some external controller or a manual process removes it.
Yeah. Yeah. Okay. Yeah. There is a separate issue about, like, can we, like, mess around with the back off, or not back? I mean, either the back off counter or the restart number to, like, kick somebody back. That's kind of, that I consider that out of scope for this.
Okay.
So that is like another, like, thought direction. And I also think that overlaps a lot with this idea of, like, can we get Kubelet to know, like, how much Kubelet can take so it can, like, say yes or no, because there's kind of lots of angles that this could be changed at if we also expose configuration for, like, the back off counter. So yeah, that is, like, in the back of my mind, but yeah, it's not like the top-iest use case of this.
I like the idea of having a kubelet budget, right? And we also need something like that for probes. Like
Yeah.
right now, someone can DDoS a node by just creating too many probes running too frequently.
Yeah, and I think, there's what I think we can do and would be useful for 132, and there's, like, that which I really also think is important to integrate with this and with all the other in-flight stuff, like sub-second probes, or if we do something with back off counter, or yeah. So consider this also a call to friendship for anybody who is thinking of working or is currently working on something that like Kubelet would need to, like, partition resources out to, like, spin off probe workers or spin off anything else. And I want to talk to you about what your life is like and if we can work on this together. Okay, well, please, yeah, send me a message if you're interested in this, comment on this presentation, DM me. I'll probably show my face again. I put myself back on the schedule a little bit later too as I get more info back. So yeah, see you on the internet. Thank you.
All right, thanks, Laura. I suggest that you move this to the right column in the project board as a candidate for 132.
I will.
Yeah, thank you. All right, so next up we have Peter with suggestions on the node Kep Wrangler, role.
Yeah, so this is just, I've begun sort of drafting up a document describing the Kep Wrangler. We talked about this a couple weeks ago, I think. Mostly this is just a call for people to put in their ideas of what this could look like. I put down some of the motivation and some of the problems we're trying to solve into this document. which I would share, but my screen sharing, I think, doesn't work because I use the native app. Yeah, that's just, this is mostly just a call for action. I think it would be cool if we could get some semblance of this put together for 132, which I believe we'll begin doing planning for soon. So I figured we could start the conversation of what we actually should be implementing.
Yeah, I think sounds good. I think last time we raised this, there was interest from the community. Some folks, I think Francesco and some others had expressed interest in joining such a team. So maybe we have a call for folks who are interested being part of release team for Node for 132, and maybe have 2-3 folks being the KEP wranglers. And when we plan 132, we assign one wrangler per KEP, and then they'll be monitoring those KEPs, like pinging chairs, approvers, basically guiding new contributors through the process. And if they know that something is not going to make it, then we can move it off the board with their help. So there's a good visibility and tracking of KEPs throughout.
Yeah, totally. That sounds about what I was imagining.
Okay.
Cool.
Not
I didn't
sure
have anything
if
else.
folks have any more thoughts on it. Yeah.
Sweet. Thank you. That's all for me then.
All right.
Thanks.
Yeah, thanks. So I think, yeah, that's the end of the agenda for today. Do folks have anything else they want to discuss? All right. If not, I think starting next week, we can start going through 132 planning. So we start organizing ourselves and prioritize what we want to focus on as SIG Node. All right. Thanks for joining. See you all next week.
Bye. See ya.
Thanks.